So, Jay Prakash sir, so one session is already done, but for some participants who were not at that time, I will give brief introduction of who Sir Jay Prakash sir is. So, Dr. Jay Prakash sir has received his MSc and MPhil in mathematics from Sambalpur University, MTech and PhD in CS, cryptographic protocols from Utkal University. He is a visiting researcher of Department of Electrical and Computer Engineering, University of Waterloo, Canada. Currently, he is working as professor in Department of CSE, the LNM Institute of Information Technology, Jaipur, India. Professor Kar is the central lead of Center for Cryptology, Cyber Security and Digital Forensics. His current research interests are on cryptographic protocols and primitive using elliptic curve and shading-based cryptography in the random oracle and standard model, zero-knowledge proof, secret sharing, and multi-party computation. Professor Kar is an advisory and editorial board member of many peer-reviewed journals and international conferences. He is the life member of the International Association for Cryptology Research, Cryptology Research Society of India, IEEE senior member and associate member of ACM, International Association of CS and IT, Singapore, and International Association of Engineers, US. Professor Kar has received several sponsored projects funded by Data Security Council of India, NASCOM, Department of Science and Technology, Government of India, National Foreign Special Program of Ministry of Science and Technology of China. So handing over to you, sir, for further proceedings.
Okay, thank you very much. Nice introductions. So it is my privilege, and we can start the talk. Last yesterday, I have a one session, and I have covered certain parts from the cryptography and the basic cryptographic primitives, certain public key crypto system, asymmetric crypto systems. So today in sessions, I would like to cover a certain part on introduction part on the blockchain. Anyway, many of these things has been covered, I hope, in the blockchain, but the certain and but certain parts, if it's also, I would like to again to repeat because these are very much important. The cryptographic primitives and that is used, and as well the hash function that is used in the blockchain, and what is exact security behind it, that I would like to discuss. So anyway, first some introduction part from the blockchain. Somehow it has been covered. So just repeating certain parts might be you are not aware of that. And after that, I will start that particularly the Bitcoin. How the Bitcoin is generated, what is how the transaction is being signed by a cryptographic that is the digital ledger, algorithms, and what is the security behind it in the algorithms, that is important in this. So share my slides. This is my just is it visible my slide? Is it visible? Is it my slide?
Yes, sir.
Yes,
Dear
Yes, sir.
participant, is
Slides are
visible?
visible and
I have shared my slides. Can please anyone can confirm that this slide is visible or not?
sir, slides are visible, sir.
Is it okay?
yes,
Okay,
sir,
fine.
visual, sir.
Okay, fine. Okay. Uh, so first is that I want to also cover the fundamental part that I told on the blockchain and elliptic or digital signatures algorithms. It is in the short form, it is written as ECDSA. That is your elliptic corp digital signature algorithms. Somehow, before starting that, let me first introduce what is exactly this blockchain. And anyway, it has been many of these have been covered in your the other sessions. I am repeating certain part. Basically, the blockchain is a digital, decentralized, distributed public ledger database where blockchain are linked cryptographically and transactions are digitally signed and managed using the consensus model. So here, if you will observe here, digitally signed, right, and is linked cryptographically. So while this blocks is to be linked cryptographically, that means it needs to be used the hash functions, particularly the secured hash algorithms too, which generate the 256 bits, right? And so it is a collision resistance function. What is this? The beauty of the secured hash algorithms or the hash algorithm is that it is collision resistance and it is the one way. So uh, I will be also explaining exactly what is the security in these hash functions. So cryptographically, it is linked. That means through the secured hash algorithms 2 or secured hash algorithms 1, but secured hash algorithms 1 which generate here the 120, oh, sorry, 160 bits, and it is called the message digest, and it generate a fixed length also, and is managed after that is managed using consensus model, right? Consensus model, that is the various consensus are there, that for example proof of stake, proof of work, like that. So I will be coming to that part. And each block content timestamp, this is very important. So we cannot skip the timestamp, but we have must have the each block content the timestamp and a link to the previous block. So the link that I told through the hash values of the previous one. So I am showing the structure of that of the blockchain, and it basically form a chain of blocks. And the beauty of this is it cannot be altered once they are added to the blockchain. So if you look to this structure, it will look like this. There are three blocks here: block one, block two, and block three. And look here, the hash values, that is the digest, is 6U9P2. So this is linked to the previous hash. So previous hash is that is 6U9P2. That is the previous hash. It is linked to this next block. That is the block two. Similarly, these hash values again it will be linked to the block three. So in this way, the linked all the block has to be linked. It does not mean that only the three blocks. Just I am showing this structure. There are multiple blocks exist, and this is a common structure in the of the blockchain. So there are few preliminaries, the vocabulary while discussing the blockchain. First, the blockchain that I told, it is a decentralized distributed ledger. uh, it records all the transactions on the multiple computers so that the record cannot be altered reactively without the alteration of the subsequent block and the consensus of this network. This is the most important of the blockchain. It is the most important part of the blockchain. Now, other one of these most important term it exists, that is the cryptocurrency. So I will be more details will be going to explain what is exactly the cryptocurrency and this Bitcoin. Cryptocurrency, it is nothing but a digital or the virtual currency. It uses the cryptography for secure financial transaction. So, and the Bitcoin, a decentralized cryptocurrency. Bitcoin is nothing but a cryptocurrency and it is work in a decentralized server, decentralized cryptocurrency. That's why it is called the decentralized cryptocurrency. And it uses peer-to-peer technology to facilitate instant payment. So it is the first and the most widely used cryptocurrency. Then the next term is coming in this blockchain is the distributed ledger. So what is exactly the distributed ledger? A ledger of digital transaction that is stored and maintained by network of computer rather than a central authority. Here there is in a decentralized way its work. That's why its name is here the distributed ledger. Then the next term is coming the mining. Hopefully all this have been covered. Somehow I am repeating this one so that you will be more clear the part that I will be going to cover. So the mining is the process of adding the transaction records. So there are the series of the transaction. Now, if you would like to add some transaction, so you may add the transaction to this record to the blocks public ledger. That is the public ledger. In this case of Bitcoin, mining involve solving complex mathematical problem in exchange for a reward in the form of cryptocurrency, right? So this is about the certain term that is basically used, that is the part of the blockchain. The apart from that, other is that is the node. What is exactly this node? Node means we understand a computer that participate in the operation of the blockchain network. So you don't be confused that a peer-to-peer that is also a computer, and this node that I am saying, it is nothing but a computer and it participate in the operation of the blockchain network. Other term that is used is the smart contract. What is the smart contract here? Smart contract is a self-executing contract with term of the agreement between the buyer and the seller. There are two entities involved here. There would be a one agreement. So in term of that agreement, it is the basically it is a self-executing contract, right? And buying and seller being directly written into lines of code. So that is written into lines of code. The code and the arrangement contained therein are stored and replicated on the blockchain network. So other term is there are various the smart contract, and now that there are the open source code are available that you can write in the Solidity and can find this gas cost. Or we are not going to go to the more detail about the smart contract. Anyway, I hope that it has been covered. And the other is that another is the most important thing is the consensus. So the agreement of the majority of the node on a blockchain network to the validity of the transaction or blockchain transaction. This is called known as the consensus. And the other is that is the cryptographic primitive that is used is the hash. So hash that I told, it is the cryptographic hash function and a unique fixed size alphanumeric strings that represent the content of a block in a blockchain. Suppose it is the fixed size of alphanumeric. This is marked here. Fixed size of alphanumeric. For example, if you are executing this hash on the some information, suppose m, it generate the digest and each of the fixed size, and its string is the alphanumeric characters, right? And other term that is the private key, a secret piece of data that is used to access the cryptocurrency stored in a wallet. It should be it should be kept secret and secure. It cannot be made public. So as it follows the owner to spend transfer these their cryptocurrency. That's why here the security is the most important part, that in this, that is the private key. And so blockchain this integrate the following innovations. So first is, if we will look here, the blockchain peer-to-peer network, and the security of this blockchain also that is based on this cryptographic primitive that I told, that is the cryptography. And other is that the smart contract and the consensus mechanisms. So these are the few all these components. If we will integrate, then basically we can say it is the blockchain have the all these components. And the key characteristics of blockchain is it is open. Anyone can access the blockchain. So no need to keep any things or any entities to keep away, not to allow to access the blockchain. It is very open. Anyone can access the blockchain, and it is distributed or the decentralized. No doubt, it is distributed and decentralized. There is no any centralized server. not under the control of any single authorities. So there are the many the peoples or the entity that involved can access. So it is allowed to everyone. It work in a distributed way. So and definitely it is no doubt it is efficient in the sense it is fast and scalable, right? So the execution or is very fast, the computational time is very less, and no doubt it is scalable also. As well, it is verifiable. Everyone can check the validity of informations. So whatever the information that it can be verified, so the verification, the transaction is being signed through a digital signature, and it can also it is verified. Definitely it is verifiable because each node maintain a copy of transaction, right? And permanent. So it is no doubt that you cannot remove that one. It is permanent. Once the transaction is done, it is persistent and cannot be altered. So no one can alter or can change or modify the information or the once the transaction being performed, right? So that we can say it is persistent, and it cannot be altered or modified. So there are few history that I would like to discuss on the blockchain, how this blockchain came. So basically in 1991, the researcher scientist named that Sweat Haber and W. Scott introduced the blockchain technology. In this system, the timestamp documents are stored in chain of blocks. So it is invented in the 1991. After that, in 1992, Merkle trees form a legal corporations by using system developed by Stock Harbor and W. Scott with some more features. So Merkle used a secured chain of block which store multiple data record in a sequence. In 2004, cryptographic actives Hal, that is for the securities. Cryptographic activist Hal Finney introduced a system of for the digital case known as reusable proof of work. This is important, and this system help other to solve double spending problem. Many times, the it's observed that it is spent and multiple times. So to avoid or to resolve this issue, that they introduced that some cryptographic techniques by keeping the ownership of token registered in a trusted server. So for that, they basically used to a trusted server. So the main idea came in the 2008 by Satoshi Nakamoto. It's conceptualized the concept of distributed blockchain under his uh, the white paper, a peer-to-peer electronics case. He modified the model of Merkle tree. Before that, the Merkle tree is used, but in 2008, but the Satoshi Nakamoto modified this uh, 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 distributed blockchain and sorry, the Merkle tree, modify the Merkle tree and create a system that is more secure and contain the secure history of data exchange. His system follow a peer-to-peer network of time stamping. His system becomes so useful that the blockchain becomes the backbone of cryptography. In 1982, David, the first ever blockchain protocol in his dissertation, computer system established, maintained, and trusted by manually suspicious groups. So these are the few history of the blockchain. Other is that how the Bitcoin came. The history of Bitcoin in 2008, idea was published under the pseudonym Satoshi Nakamoto. 2009, start the Bitcoin network. 2010, first cryptocurrency stock exchange is launched in 2011. One Bitcoin equal to USD uh, 20,131.31. Bitcoin equals one. These are that you may find certain literature from there. I will not be going to cover the more details about that. Now, this is the history of, if you will, summarizing the history of this Bitcoin. So, the 2008, the idea was published. 2009, the idea was published by Satoshi Nakamoto. 2009, it started the Bitcoin network in the 2009. And 2010, the first cryptocurrency it's launched, and that is the in the stock exchange. 2011, one Bitcoin equal to one USD, and it is defined. It is announced. And 2013, one Bitcoin is equal to 100 USD. 2014, Microsoft accept the Bitcoin. Earlier, the Bitcoin was not accepted by any agencies. In 2017, one Bitcoin is equal to 10,000 USD. So this is this few history of the blockchain. So somehow the fundamental of blockchain that I will be just it is having the six stages. First was the first phase is the transaction is required here, and the second is that a blockchain that represent that transaction is created, and third stage is the block is sent to every node in the network. At the fourth stage is nodes validate the transaction. So here the transaction is being signed and here is to be validated, is to be verified. And the fifth phase is that is a node received the rewards for the peer of network. And the stock is thus is added in the to the existing blockchains. And finally, it generates the transactions is complete. It's completed the transaction. So this is the fundamental of the blockchain. So basically, the majorly four type of blockchain exist, and it can be is categorized like the here the permissionless and permission. Two type of the blockchain. Again, the what are these permissions less? Permissions less, that is here the one type is that is the public, other is the hybrid. So here in the public blockchain, no centralized authority exists, right? So there is no central server that means can work in this case of this it is work in a decentralized way. And in case of hybrid, it controlled by one authority with some permissions process, right? So it is the hybrid one. So public and the hybrid is common to the permissionless and the permission. So other category of the type of the blockchain is the private. It is controlled by one authority. That means it is controlled by one server. That is a centralized server. And there is another type of it is a special type of this blockchain that is called that is known as consortium blockchain. It is controlled by a group of peoples, by a group that means, right? So we can categorize this blockchain in this way. So what is exactly this blockchain? Sorry, the public blockchain. So it is permissionless distributed ledger. So permissionless distributed ledger on which one body can join and conduct the transaction, right? So one body, that means one blockchain is to be joined, can join and is conduct the transaction. It is a non-restrictive form of the ledger in which each peer has a copy. This also means that anyone with an internet connection can access the blockchain. This user has access to historical and contemporary records and the ability to perform the mining operations. How the mining operations work, I think that has been covered. So these complex computations must be performed to verify transaction and add them to this ledger. So on the blockchain network, no valid record or transaction may be altered because the source code is usually open. Anybody can check the transaction, uncover problem, and suggest fixes. So this is about the public blockchain. So what are the advantages and disadvantages of the public blockchain? There are several advantages and disadvantages. Both the advantage and disadvantages are there of public blockchain. So the advantage is it is trustable. Uh, Public blockchain nodes do not need to know or trust each other because the proof of work produce procedures ensure no fraudulent transactions, and definitely it is secure. A public network can have as many participants or node as its one, making it secure network. The higher up the network size, the more records are distributed and more difficult it is for the hackers to hack the entire network. And other advantage is open and transparent. The data on public blockchain is transparent to all members of nodes. Every authorized nodes has a copy of the blockchain records or digital ledgers. So blockchain records or digital ledger, definitely there would be a copy of it with the each authorized node. So there are definitely certain disadvantages are there in the public blockchain. So the one of the most is that is the lower transaction per second. The number of transaction per second in a public blockchain is extremely very low. So number of transaction is very low. So this is because the in a large network, since it work in a decentralized way with many nodes, which takes times to verify transaction and do proof of work. So the computational time definitely it is more because that it's involved the proof of work as well. There would be to verify the transactions, and since there are many multiple nodes exist here, so definitely the number of transaction per second is very low. And it is there is also the scalability issues in the public blockchain. This is also one disadvantage. Its transactions are processed and completed slowly. This harm scalabilities. So no doubt if it's take the execution time it's take much more time, so the transaction are processed and completed slowly, so definitely the scalability issue will come. So because the more we try to expand the network size, the slower it will become. So if you want to increase the network, the size of the network, definitely it will be slower. And other disadvantage is it's consume the energy consumption is very high energy consumption. So the proof of work device is expensive, right? Since the proof of work is there, it is a one consensus algorithms. It is very expensive and requires a lot of energies. So the power consumption is very high. So technology will undoubtedly needs to develop energy efficient consensus mechanism, because in this case there is the hash function is used. And since the cryptographic primitive, the hash function cryptographic hash function is used, and it's the energy consumption is very high in the hash functions. So that's why it is a one disadvantage. So what are the various application of public blockchain? So one of the most important application is in the voting. So governments can use a public blockchain to vote, ensuring openness and trust, because it work in a decentralized way. Then fundraising, that is the business or initiative can use the blockchain to improve transparency and trust. So other category of blockchain is the private blockchain. So private blockchain, that is it is the network that operate in a private context, such as restricted network. So it is not allowed to everyone. It is restricted. That's why it is a restricted network, or is controlled by a single identity, or it is controlled by a one single server. So while it has a similar peer-to-peer connection and decentralized to a public blockchain network, this blockchain is far smaller. They are often run on a small network within a firm or organization rather than open to anybody who wants to contribute processing power. So permission blockchains and business blockchain are two more terms for them. So you can see the other name, it is the permissions blockchain, and also it is sometimes called the business blockchains. What are the various advantages of this and the disadvantages of private blockchain? So advantage is speeds. It have the higher speed because there is a one, it is controlled by a one single entities or one single server. So private blockchain transaction are faster. This is because a private network has a smaller number of nodes. There is no much more network, the number of node involved here in this network, which certain this time it takes to verify the transaction. It is scalable. You can tailor the size of your private blockchain to meet your specific requirements. So this makes private blockchain particularly scalable since they allow companies to easily raise or decrease their network size. So this is the advantage of the private blockchain. So what is the disadvantage here in the private blockchain? Trust building. In a private network, there are fewer participants that in a private network, right? So definitely you cannot rely to the all these participant who involved in that network in the network. So it have the lower securities. A private blockchain network has fewer nodes on the member, so it is more vulnerable to a security compromise, and it is centralized. So private blockchain are limited in that they requires a central identity and access management system functions. This system provide full administrative and monitor capabilities. So the uses of private blockchain. So the main most important application of the private blockchain is supply chain management. So a private blockchain can be used to manage company's supply chain. Asset ownership. A private blockchain can be used to track or and verify assets. Then internal internal voting. Internal voting is also possible with a private blockchain. So in many times the private blockchain, they many in the all the application they prefer to use the private blockchain. But the here the constant is here the more number of participant here cannot be involved. It is a very smaller size network. And other type of this blockchain is that hybrid blockchain. So in case of the hybrid blockchain, organization who expect the best of both the worlds use a hybrid blockchain. The advantage, certain advantage of the public blockchain, and few advantage that is achieving in the private blockchain. You can combine both and can form a hybrid blockchain. So which combine the features of both the private and the public blockchain. It enables enterprises to construct a private permission-based system alongside a public permission-less system, allowing them to choose who has access to certain blockchain data and what data is made public. In a hybrid blockchain, transactions and records are typically not made public, but they can be validated if necessary by granting access via smart contract, right? So this is about the hybrid hybrid blockchain. So also hybrid blockchain have certain advantage and the disadvantage. So advantage, no doubt it is secure. Hybrid blockchain operate with a closed environment, preventing outside hacker uh, launching a 51% attack on the network. And it is cost effective. So if it also safeguards privacy while allowing the third party contact. Transactions are inexpensive. The transaction cost is very less and quick, scale better than a public blockchain network. But there is a disadvantage in this hybrid blockchain: lack of transparency. So because the informations cannot be hidden, this type of blockchain is not completely transparent, right? So here the information, if you want to keep secret, or the one we keep cannot keep secret. So less incentive, upgrading can be difficult, and users has no more incentive to participate in or contribute to this network. So these are the advantage and the disadvantage of hybrid blockchain. So there are certain application of hybrid blockchain. So in the real estate, it is the many of the real estates they prefer to use the hybrid blockchain. So real estate company can use the hybrid network to run their system and offer informations to the public. Then in retail, the hybrid network can also help the retailers streamline their process. High regulated markets, hybrid blockchains are also well suited to highly regulated areas like banking sectors. So these are the few applications of hybrid blockchain. Then the last category of the blockchain is consortium blockchain. In the same way that the hybrid blockchain has both the private and public blockchain feature, a consortium blockchain, also known as the federated blockchain. However, it differs because it involves various organizational members working together on a decentralized network. Predetermined nodes control the consensus method in a consortium blockchain. It has a validator node responsible for initiating, receiving, and validating transaction. And the transaction can be initiated or issued by the members node. This is about the consortium blockchain. The various categories, the characteristics of the blockchain, the this is very important. Data immutable capabilities. This is the topmost features as it ensures that no data is corrupt. That means that should be the integrity preserved. How this work is that every node on the system has a copy of this ledger, right? So that means it ensure that the integrity, that the no data is corrupt. So to alter any data, there must an unanimous agreement of every node. This make blockchain secure and transparent. And we have discussed that it is the decentralized. So blockchain is decentralized, meaning that no authority or government or a group of person or a single individual control this technology. Rather, is a group of nodes that manage the whole transaction. Single source of truth, that is, in a blockchain, there is only source of truth, the distributed ledger. So to know who own what or to study particularly the transaction, you only needs to go to one place. Then the another characteristics of the blockchain is transparency or provenance. Every transaction, be it tangible or non-tangible, can be traced from the start to finish the blockchain. Consensus algorithm. Every blockchain technology has a consensus algorithms like the proof of work, proof of stake, like that, which makes the blockchain technology higher effective. All the actions are verified and approved on the blockchain using consensus algorithms. Then come to the distributed shared ledger. So what is exactly this ledger? A ledger is nothing but a record of all relevant transactions, right? A shared ledger allows the authorized participant to access, monitor, and analyze the state of a transaction in its life cycles. And what is the security here? So that, as I told, each block is to be joined through the hash functions, right? So the hash function that is used the SHA-2, which generates the 256 bits. That's why SHA-256 cryptography algorithm is used for hashing. Further, fixed length hash output value is generated irrespective of the input data length. Whatever this length here, for example, whatever this length of this data here, suppose 1024 bits or whatever it is there, so it will generate the digest, the size of edge is, that is the 256 bits if you are using the SHA-2. So irrespective of input of data length, whatever the data length, the data size, it is generate the fixed size. So this makes it is difficult to hack. Also, the component that goes into the blockchain generation increase the difficulty level of hacking. Then the auditable, the, or you can say provenance, the chain act as a trail of transaction. Timestamp help in proving the sequence. The blockchain act as a as an archive, the blocks are ready only for their lifetimes. So therefore, the system facilitates auditability and prevents any times. Other is the most important security a requirement of the distributed share ledger is it is anonymous. It is true that every transaction is transparent and open to the public, but the actual person are kept anonymous through the addresses. For example, suppose a person sent a sum of money. The receiver will know that the sender is linked to a Bitcoin address, but they will not know the actual address. There are several reasons for this. One, them is privacy. Privacy and security, that is the privacy in the blockchain is one of the key aspects of future blockchain. The network allows the users to keep their data in control while also providing a secure data storage option. The idea of a distributed ledger is not totally new. Many organizations do maintain data at different locations. However, each location is typically on a connected central system which updates each one of them periodically. This makes central database vulnerable to cybercrime and prone to delays since a central body has to update each distantly located node. And distributed ledger technology refers to a type of database that is spread across a network of computers. Each computer in the network has a copy of the database, and all copies are updated simultaneously while a new transaction is added. So here we can ensure the alterations of the data. That means there is no data is or cannot be altered. So the distributed ledger technology is used to create decentralized system that do not rely on central authority to process the transaction. The most well-known example of decentralized technology is blockchain, which is the technology that powers cryptocurrencies like Bitcoin. Other example of distributed ledger technology include Hashgraph, Tangles, and Corda. So just I am giving few idea about the architecture of blockchain. These are the core blockchain architecture components. It involves a node, the user or computer within the blockchain architectures. Each has the independent copy of the whole blockchain ledger. And it involves the transaction, the smallest building block of a blockchain system, record, that means it's contain the record, that is the record information, etc. that serve as the purpose of blockchain. Then the other is that is the block. What is exactly block is nothing but a data structure used for keeping set of transaction which is distributed to all nodes in the network. It's produce a chain. What is exactly change? The connection of the block through the hash function, a sequence of block in a specific order. Then it involves the miner, a specific node which perform the block verification process before adding anything. So before adding anything that it needs to be verified, that would be the block verification process. It must have to perform the block verification process. So whenever adding any new node to the blockchain structure, adding the anything to the blockchain structure, it needs to be verified. So this is known as the miner. Then the consensus protocol, a set of the rules that would it involve a set of the rules or the arrangement to carry out the blockchain operations. The sequence of the rules or the arrangement, and it involves the cryptographic primitive that is the hashing, a hash like the fingerprints. I will be more elaborately going to explain what is exactly the hash function is used while I will explain the elliptic digital signature algorithms after that, after covering these things. So a hash is like a fingerprints. So it is unique. It cannot be matched with anyone. Like
that is like your the fingerprints. So same digest. Suppose this is a hash function. This is the message. It generates the hash values, that is the digest is h. Again, if you would like to generate the same hash value on the different message, let it be mdes, so it cannot be possible. So it is computationally basically infeasible to generate the same digest on the different messages. So the hash, it is like a fingerprints, long records consisting of some digits or the letters. Each block hash is generated with the help of the cryptographic hash algorithm, that is your the SHA-256. Consequently, this helps to identify each block. So since it is the unique alphanumeric strings, so it is by on the if you will observe the strings, that you can easily identify the block in the blockchain structure. So the moment a block is created, it automatically attach a hash, right? While any changes made in a block affect the change of a hash too, right? Suppose if it is altering or changing, you needs to you are changing, then it will affect made in a block. It affect the change in the hash values. So simply stated, hashes help to detect any change in the block. So blockchain employ some famous hash algorithm such as SHA-2, that is SHA, or you can say SHA-256, Federal Information Processing (FIPS), and elliptic corp digital signature algorithm that I will be going to explain to you. So the cryptographic primitive it is used, the most important cryptographic primitive used is the public key and the private key, and digital signature, that is the owner unique identity, and it involves the network, that is the interconnection of the node. It involves the ledger, store the transaction details. Any new record or the transaction within the blockchain implies the building of a new block. Each record is then proven and digitally signed to ensure its genuineness. Genuineness. Before this block is added to the network, it should be verified by the majority of this node. This is important, right? If the verification does not hold, the block block cannot be added to the blockchain structures. So this is the idea here. So after that, I will be going to start the uh, cryptographic primitives that is being used, mainly the elliptic digital signature algorithm that is used in the blockchain. So certain part, last sessions that I have been covered, and few I will be going to explain to you. So certain mathematical hard problem that I have explained. So the elliptic digital signature algorithm, the security of that, the elliptic digital signature algorithm that is used in the blockchain, that is the security is relies on the discrete log problem. So I am moving to that part. Just a minute. First, last sessions also I explained the digital signature algorithm. Somehow I will be repeating this one because once you understand, then it would be easy for you to understand the elliptic digital signature algorithms. So, as I told you, what is exactly the digital signatures? So, like you think about your the handwritten signatures. Suppose if you are bringing any documents or any files, suppose if it don't have any signatures of the authorities, then it cannot be acceptable, right? So it is if you cannot say it is an authenticated documents. Basically, in the other word, you can say like this. In a similar fashion, we use that digital signatures. So But in the handwritten signature, there is no any tools exist or technique exists to verify the signatures. But in case of digital signatures, there would be another algorithm exist which can be used to verify these signatures. So basically, a digital signatures, the most important security requirement or security goals that can be achieved from the digital signatures is the authenticity, then non-repudiations. Digital signature is coming under the public key cryptography. Public key cryptography that the last sessions anyway I have explained to you. So authenticity, non-repudiations, and integrity. So these are the three most important security requirements that can be achieved through the digital signatures. And digital signature is coming under the public key cryptography. So basically, digital signatures, it comprises three algorithms. One is the parameter generation. Parameter generation. Second is that the signing algorithm. Third is the verification algorithm. Right? So the parameter generations, what are the parameters is being used to for the signing on of a message and to verify that is generated in this particular algorithm. And you can say it is a one-time task, right? So all the public key and the private key that are being generated or being constructed in this particular algorithm. Apart from that, other parameters that are being also used for the signing and the verification also uh, uh, generated in these algorithms. And the second algorithm is the signing algorithms, and the third is the verification algorithm. In the verification algorithms, there will be a one verification equation is used while the recipient receive this message and the signatures. So basically, it is the communication between the two entities, like say Alice and the Bob, or you can say any two entities, two devices, or two devices also you can say, or two entities, or it is the two machines while communicating with each other. Let me take think about the two entities involved here, Alice and the Bob. So Alice has to sign the message M. Let the message is denoted by M. Alice has to use her own private key to sign this message. So Alice has to use the signing algorithms, sign on the message M, and generate the signature. Suppose the signature is denoted by sigma. Then Alice will send the message and this signature sigma to Bob. While Bob received the message and the signatures, Bob has to verify the signature. So how the verification is to be performed? That Bob has to, there will be a verification algorithms. He has to use the verification algorithms. That means there will be a one verification equations. So if this two parameter passes through the verification equation, then only Bob will accept this message and the signature, otherwise reject. So in which case it will be rejected by the recipient. If the message is tempered, definitely it will not pass through the verification equation, right? So definitely the recipient will uh, confirm that during the time of the communication the message has been altered, right? And suppose how the authenticity achieving here, the security requirement. So because if the verification hold, then the Bob will confirm that from the authenticated source he is receiving this message, definitely he will accept this message, right? And non-reputation, in many time, this is one of the most important security requirement. In many time when the two entities or two party communicating with each other, certain time the sender or might be the receiver will deny. Deny means he will not receive the information, or might be the sender will say that he will regret that he has not sent these informations. So how to protect this one? See, by using the digital signature, this can be achieved, this security requirement. So Alice cannot deny. Why? that he has not sent, she has not sent this message. Why? Because Alice is using her own private key. No one and to generate the signatures. So no one can construct the private key of anyone. So that's why the integrity preserved here. So this is the idea about the digital signatures. So, and it is coming under the public key cryptography. So digital signature algorithms here, the security of the digital signature algorithm, it relies on the discrete logarithm problem, DLP. It is in the short form and the more elaborately that I explained in last session. What is the discrete logarithm problem? I will not be going to repeat here now. So the first algorithm is the key generations for the digital signature algorithms. Here, we need to select a prime number q, which lies between 2 to the power 159 and 2 to the power 160. We need to first choose a prime number in between these two numbers. Then we have to set a integer t, which lies between 0 and 8, right? And select a prime p such that this p lies between 2 to the power 512 plus 64t. The t is to be chosen from here. For example, if t, the value of the t is 2, so this would be 2 to the power 511 plus 64 into 2, whatever it is there, 128 plus 511. So 2 to the power that, and 2 to the power 512 plus 128, right? So the prime number is to be chosen in between these two numbers, and in such a way that you have to choose that q must divide this p minus 1. So whatever the prime number you are choosing, the if that the p minus 1, it must be divisible by this q, whatever the q you have chosen, the prime number you have chosen. This is the condition of the digital signature algorithm while setting the parameters. Then we need to set a one cyclic group of order q in ZP star with the generator alpha, right? And of order q, right? And already the q, that is the prime number that you have already chosen here. So you have to take this generator, or this is a special element which order is q, right? And that is the prime number q and is to be chosen. Then select an element g randomly here and compute this alpha is equal to g to the power, the alpha is the g to the power p minus 1 divided by q, okay, modulo p. And suppose while you are choosing this, setting this alpha, might be alpha maybe sometime is equal to 0, eventually might be sometime it is 0, sorry, it is equal to 1. In that case, again you have to choose the another element g from ZP star. So you have to set this alpha in such a way that alpha should not be equal to 1. This is the condition. Then select a integer a in randomly in between 1 and q minus 1, right? A is to be chosen from 1 and q minus 1 randomly, right? And compute this value of compute y is equal to alpha to the power a modulo p. So here we consider this y is the public key. That is, along with this y, other parameters also we are considering taking as the public key or the public parameters y alpha p, right? And the private key is, that is the a. So the how this signature is being generated on a given message. So first the signer has to choose key randomly in between 0 and q, right? And compute this alpha to the power key modulo p, again on compute on modulo q. Let it be equal to r. So this is just the simple exponents operations, alpha to the power key modulo p, again compute on modulo q. Then find the inverse of it. So inverse of key, that is k inverse you compute, that is the k inverse modulo q. Whatever this key you have chosen randomly, just then you compute the inverse of it. Then on a given message M, the signer has to generate the signatures. First, the signer has to execute the hash function on this message M and generate the digest. For example, this is H. Then use the private key. The signer has to use his own private key A and multiply with this R. What the R has been computed here, AR, and add with the digest, that is H. AR plus H. H is the digest. After executing the hash function on the message, it's generating the digest. And as I told that, irrespective of this length of this data or the information, it generates a fixed length and is the alphanumeric. Okay. So in case of your the SAR2, it generate 256 bits, which is used in the Bitcoin that we discussed. So now, after obtaining this digest H, multiply this private key A with this R and add these two parameters, two integers. And then you multiply with the inverse of key and compute on modulo Q. And finally, and it is equal to S. And finally, it generates these two parameter R and S. So R is, that is nothing but your the alpha to the power k modulo P modulo Q, and S is, that is the k inverse HM plus AR modulo Q. So these two parameters is considered as the signature on the message M. It is generated by sigma. Then this sigma and the message is being sent to the verifier or to the receiver. In this case, we are considering, suppose Alice and the Bob. Alice will send the message and the signature sigma to the Bob. Then Bob will use the verification algorithm this and verify the signatures. First, how the verification will be done? First, Bob has to collect the authentic public key of Alice from the public key directory. It must be certified, right? So Bob has to obtain this public key, that is P, Q, alpha, and Y. First, verify that whatever the sigma is, that is your the RS, first needs to be checked. The verify needs to be checked. Both these two parameter R and S, whether it lies between 0 and Q or not. If it does not, it is not in between the 0 and Q, then straightforward it will reject. The receiver will reject or the verifier will reject the signatures. So first of all, it needs to be checked whether it lies between 0 and Q or not. 0 and Q or not. The Q, that the prime number that you have chosen. Then compute the inverse of S. S inverse modulo Q and compute this HM. Because the receiver Bob is receiving this message, what the message is received, execute the hash functions and compute the hash functions. Suppose is equal to, this is H. Then its compute W into, let the S inverse is equal to W. Then multiply this W with HM, WH with the digest, and U2, this is U1, and U2 is equal to R, that is the other parameters of the signatures, multiply with this W, it is denoted by U2. Then compute alpha to the power U1. Alpha is the public parameters, that is already I have told you. Alpha to the power U1, Y is the public key, and to the power U2, compute on modulo P and modulo Q, and let it be equal to V. Then we have to check whether this V is equal to R or not. If V is equal to R, then the receiver That means the Bob will accept the signature, other will reject the signatures. Okay. So this is the proof of correctness. How this proof of correctness means how this v is equal to u alpha to the power u1 by u to the power u2 is equal to r. So we must have to check the r that we are taking. So whether these two r would be same or not. This can be verified through the proof of correctness. So I will not be going to discuss this. So I will be going to share the slides. So just have a look into it. So then uh, other type of the algorithm is that also the Elgamal signature scheme. So this is a different another type of the signature scheme that I will be going to discuss. I will not be going to discuss this on the Elgamal signature scheme, right? So I will be more focusing on the elliptic or digital signatures algorithms. There are the various attack in the digital signatures. So let me first cover this elliptic or digital signature algorithms. Then, if the time permit, then we will discuss on that. So before discussing, first the elementary concept of elliptic curve. How this we see the elliptic curve digital signatures algorithms. So here basically we are considering a one elliptic curve over a field that is key. It is denoted by key. So E is defined over the field key. So the equation of the elliptic curve here we are considering the y square plus a1xy plus a3y is equal to x to the power 3 plus a2x square plus a4x plus a6. Now the here the discriminant is of the elliptic curve is that is delta is minus d2 squared d8 minus 8 d4 d4 3 to the power 3 minus 27 d6 square plus 9 d2 d4 and d6. So this is the elliptic curve, and so this equation is called the Wester's equations and of the elliptic curve. Here the condition is that the delta should not be equal to 0. That means there is no singular points on this curve. So the set of all L rational points on the extension field L of K denoted by E L. It is also contained the point at infinitives. So the elliptic curve, if A1 is equal to 0, so the equation 3 is denoted, can be reduced in this form. Y square plus cy is equal to x cube plus ax square plus b. Okay, where A, B, C are the elements of this field that is key, for the field have been chosen. That is the prime field. Okay, if the characteristics of the underlying field is not 2 or 3, then the Wester's equation of the elliptic curve can be transferred to the following equations. That is y square is equal to x cube plus ax plus b. Now here the discriminant is that is the minus 4a to the power 3 plus 27 b square. It should not be equal to 0. So here about the group law. So the set of the rational point on the elliptic curve, basically it form a groove. So the elliptic curve that we are choosing here, I am coming to this elliptic curve. All this, that is the equation that I told. Y square is equal to x square plus ax plus b. All the point lies on the elliptic curve. All are, it form a groove, and it form a additive groove, right? So it is that means additive group means it hold the closure properties, associative properties, existence of identity, existence of inverse. That means sum of those 2 points p plus q, any 2 points if you are taking this, that means the third point obtaining R is also lies on the elliptic curve, right? So there is a special point that is called the point at infinitive, that is denoted by O. So P plus O is equal to, that is P, and the additive inverse of the any points P is denoted by minus P is equal to the additive identity O. So these are the four properties hold on the point lies on the elliptic curve. So it form a group, that is the additive group with respect to addition. Since it form the group with respect to addition, we can call it is the additive group. So the main idea here, why I am explaining the additive group, because I will be going to discuss about the elliptic curve discrete logarithm problem, where the ECDSA security of it relies on this particular problem, which to solve, so far it has, the problem has not been solved, and to solve in a polynomial time, I am telling, to solve this, it's take whatever the algorithm is been developed so far, it take the fully exponential time, not in a polynomial time it can be solved. So so this is the elliptic curve that I told. It will look like this. Now, so this is the few things also must have to know about the group order. Let E be the elliptic curve defined over the prime field. The number of points in this is denoted by this, is called the order of E, okay, over FQ. So normally we consider the elliptic curve over the prime field. The P is a large prime number. So these are the all the properties. So this is a one very simple example here. If we are considering the elliptic curve defining over the field, that is Z23, right? So the elements of this 23 are, Z23 are 0, 1, 2, 22, right? So these are the elements of this group, that are the point that lies on the elliptic curve, that we are considering, right? So the elliptic curve is defined over Z23. Here, this is a very one simple example. We are considering this P is a prime number. So now, what is the discrete log problem? Elliptic curve discrete log problem. In 1985, Neil Koblis and Victor Miller independently proposed the concept of elliptic curve cryptography. So it is based on discrete log problem, discrete logarithm problem. That is, in the short form, it is written as DLP, in a group defined by points on the elliptic curve over the finite field. So what is exactly this discrete log problem, elliptic curve discrete log problem? The generalized discrete log problem already we have discussed in the last class, last session. So the elliptic curve discrete logarithm problem is given an elliptic curve E defined over a finite field, that is the prime field FP. Let's you choose a particular point P belongs to FP. Okay. And the order of this P is N. And take a point or the elements Q. So basically this P is the generator. It forms the cyclic group which is denoted by this. Okay. And we are taking a point Q, one element Q. It belongs to the cyclic group P. What are the elements of the cyclic group? The element of the cyclic group look like this: P plus, sorry, P, P, like this. So let we choose a elements Q from the cyclic group. Now, so you have P is the generator that you are considering a generator. It is an elements. By taking this generator, we are forming the cyclic group. Q be a one particular elements from the cyclic group, that we are considering. Now here, so you have, there is a integer L, it's belongs to 0 and n minus 1. Now this Q is equal to LP. Here, if you are finding a L, just let's we take an L. After adding this P, L number of times, you are obtaining Q. Now, what is exactly the discrete of elliptic or discrete log problem here? So the Q is given to you and P is given to you and asking you to find this value of L. So it is computationally infeasible. It cannot be find the L in a polynomial time. It takes the fully exponential time. So this is the discrete log problem. But it's very easy to compute this Q. If L is known, definitely P is known. So adding this PL number of times, it is easy. That means P plus 2P like this, L number of times, you will obtain lastly LP. It's very easy to compute this LP. That means you can obtain this value of Q. But P and Q, if it is known, but is not possible to known this L. So this is the elliptic or discrete logarithm problem. The whole security is relies on this particular problem. So the Bitcoin, the security of the Bitcoin is basically it relies on this particular problem. So now come to the elliptic or digital signature algorithms. So again, there are three algorithms. It comprises the three algorithms. One is the key generation, signing algorithms, and verification algorithms. So the key generation is that select an elliptic curve E. It is defined over the ZP. So the number of points EZP, it should be divisible by a large prime, that is n. Select a point P belongs to ZP, it is a 1 point, and the order of P is n. Order of P is n. Now, select an integer D randomly in between 1 and n minus 1. It should must have to choose the randomly. Randomly means it is the unpredictable and it is the unique integers. And since you are choosing randomly, that means it is statistically unbiased. Okay. Then it computes the Q is equal to D into P. P that you have chosen, that is the generator. D you are choosing randomly in between 1 and n minus 1. And at this P, D number of times, you will obtain this Q, right? You are obtaining this Q. Here we are considering this Q as the public key and D is the private key. Okay. Now, the signature generations. So now this is the signing algorithms here. So first choose this key in between 1 and n minus 1. It is statistically unbiased, it is unpredictable, and it is a unique number. Now compute this, again this kp. P is the generator, it is the public parameters that already I have told. So compute this kp, right? Now you are, while adding this p k number of times, you are obtaining another element. Suppose this element that you are obtaining is r, and suppose the coordinate of this r is x1 y1. Then you compute this x1 modulo n, let it is be r. Okay, so definitely while you are adding this p k number of times, you are obtaining another point, that is r, on the elliptic curve that I told. This is another point that you are obtaining, suppose r, and its x coordinates are x and y coordinates are x1 and y1. Just compute this on modulo of x1 modulo n. So you will let it, we obtain is r. Now r might be equal to 0. Suppose in some case, if you are obtaining r is equal to the value of r is equal to 0, then again you have to go to statement 1 and again you choose this k, the different k. So you have to choose this k in such a way that while you are computing this r, it should not be equal to 0. After that, the message on which the signer is to be signed is to be hash. Compute the hash hm. Suppose it is h. Then the private key is used for the signing, that is d. Multiply this d with this r, with this h. Then multiply the inverse of k, that is the k inverse, right? And compute on modulo n. And this is denoted by s. So finally, we obtain this signature is RS. So let it be denoted by sigma. Then the signer will send this sigma and the message and sigma to the verifier or to the receiver. So the verification algorithms will work like this. So first, the verifier has to obtain a authentic public key of the signer. So the authentic public key is that is your the EPNQ. Verify R and S are the integer in this first verify this both the R and S. It lies between 1 and n minus 1 or not. If it is not equal to, it does not lies between 1 and n minus 1, then the verifier will reject the signatures. Then compute this EU1 H. Uh, First compute the hash value on the message M. Multiply with this W. What is W? W is the inverse of S. That is the other parameter of the signatures. That is the signature is here R S. So compute the inverse of this. It is denoted by W. And multiply this with the hash values. Let it is denoted by, let it is the value is U1. Similarly, multiply this W with this other parameter R, right? And let the value is U2. Then compute U1P. What is U1P? That means you are adding this P U1 number of times. You will obtain another point. Then compute U2Q. Adding this Q U2 number of times. Another point you will obtain. Add these 2 points. So you will obtain the another point. Let this point is, for example, suppose this is capital X, which is equal to, which is your the coordinate is x0, y0. So the V is equal to x0 modulo n. Now verify whatever the V obtained here, it will be checked whether this V is equal to R or not. If V is equal to R, then the verifier or the receiver will accept this message or the signature, otherwise reject these signatures. So this is the idea about the elliptic curve digital signature algorithms. And the Bitcoin, basically it is, that is the transaction is being signed using these algorithms. So up to this part, if anyone having any doubt, so I would like to conclude here. So a lot of mathematics, because of many of you might be you are not interested. So somehow it is very important to understand all the mathematical part. So anyone would like to ask any questions? So you are most welcome. Afterward, then we will conclude. Dear participant, anyone would like to ask any questions? So if there is no any questions, so we can conclude here.
If someone is having any kind of query, they can put up in chat box.
So anyway, I have shared my mail ID as well my phone number. Yesterday, that one of the participant had chatted me and asked my mail ID and certain query. He was having some doubts and something wants to know regarding the research on the cryptography sites. Then I have explained. If you would like to also have any such kind of information wants to know, then let me know. You may send me the mail or you may call me anytime.
Okay, sir. If anybody will be having any queries, we will give you the mail or we will send you the contact.
Yes, yes. I will share the slides, no doubt, no problem. Okay.
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 So
So can we complete? Yes, yes. Please tell me.
we can conclude. So, on behalf of everyone present, sir, I would like to extend a huge thank you for this incredibly insightful session on blockchain. Your explanation of concept were very good, and they truly illuminated a complex topic. Thank you, sir, and thank you for all the participants who were there. And thank you, sir.
Okay. Thank you, everyone. So it is my privilege that inviting this talk. So thank you once again. Thank you to everyone.
Thank you, sir. So participants, we will be meeting again tomorrow at 9.